Well, good evening, everyone. Good evening for me. Good afternoon for you. Sorry I can't be here once again, but I'm in a conference in Wilsonville trying to get good at what we do. So, today's presentation is over really sections 9.3 and 9.4. 9.3 is the law of cosine. No, I'm a mess. 9.3 is the law of sines, and 9.4 is the law of cosines. So here was a problem we did in class yesterday on Monday, and a lot of you were gone, but um, I think this is a beneficial problem, so we can all work on it together. For those of you that were here yesterday, I'm actually going to give you the answers, and you can check it. And if you got these, you can pat yourself on the back and move on to something else. And if you didn't, well, you might want to pay attention a little bit. So we were looking for AB, which is 478.25 feet, and AD, which is 760.82 feet, and AC, which is 864.79 feet. Wonderful. And if you got that or quite close to it, you're okay. We'll talk about ways to increase our precision as we go along today. So, to start with, to those of you that are new, welcome back. We missed you. Hope that Canada was beauty, eh? So here we have a quadrilateral. You're given this distance along here, CD, 411.11 feet. You're given BC, 720.51 feet. And you're given angle BAD, bad, is 84 degrees, 48 minutes, 36 seconds. To begin with, then, we know that we have angles for 3 of the 4 interior angles of this quadrilateral. So that finding angle BCD is really quite simple. Now, some of you are a little bit concerned about this minutes and seconds, but that's not a problem. I'm going to see if I can just drag a calculator in, and we can do that on here. So we can first subtract off the 2 angles that are 90s, no problem. We started with 360 because, as you all know, the sum of the interior angles of any quadrilateral is 360 degrees. So then we just need to subtract off 90 and 90, and then the other known angles, which was 84, then go second angle, degrees, which is number 1, 48, second angle. I know this is a little bit tedious, number 2, and 36. This is the one that's even stranger yet. There must be a better way, but I haven't found it. Alpha plus, which is, there it is. So now we have 84 degrees, 48 minutes, and 36 seconds. And we can just hit enter. And it gives us 95.19 degrees. While we're on the subject of degrees, we should make sure that we are in degree mode, which we are. Beauty, beauty, beauty. Okay. Now, if you want to, you can go back to minutes, hours, minutes, seconds, simply by going second angle number 4, which says go change to degrees, minutes, seconds. You can hit 4. And here is the beautiful second answer, which is whatever was up here. It's going to take the answer and convert it to degrees, minutes, and seconds. And then we can hit enter. And there it is, 95 degrees, 11 minutes, 24 seconds. And this can be very, very useful to us. If you want to keep this for later, you can hit store and then put it somewhere. This was essentially angle C, so we could say alpha, where's C? A, B, C, there it is. Store it in C. Enter. And then it'll be stored in C, and we can just hit recall, second recall, there it is, on this, above the store button in blue, and it'll be stored in there for us later. And that's a great technique to use. Okay, so now let's push the calculator over to the other side. And what in the wide world of sports is going on here? That's better. So now we know this angle here is 95.19 degrees. And that's going to help us a lot. So automatically, you look down here, and we know this angle, but we don't know this side. We don't know this side. We don't have a triangle with the opposite side down here. So this is really, even though we want to find uh, BA or AB, and we want to find AD, we're going to have to wait on that. Because you'll notice we know two sides and an included angle here. That's very useful. And you'll say, well, wait a minute, Mr. Jennings, we don't have a triangle. And you know what I'm going to say. That's right. If you can't find one, make one. So let's create a triangle right here. Triangle BCD. Okay? Now we have a triangle with two sides and the included angle. Here's the two sides. Here's the included angle, which will allow us to find this angle here. And for now, we can label that little c, that angle. I'm sorry, it's 8:30 at night and I'm tired. I've been here for 13 hours. It's not fair, the real world. Okay, so this is BD, and we're just calling it little c for now. Okay, so we have two sides in the included angle, which tells us we have to use law of cosines. If we had had any opposites, for instance, if we had known angle C and side C, then we could have used law of sines. Okay, but since we don't, we're going to use law of cosines with these guys here. I'm going to try to keep them there so they still show. Okay. So law of cosines. And from section 9.4, you know, and maybe from last year in FST, you know that c squared equals a squared plus b squared minus 2ab cosine angle C. C squared equals a squared plus b squared minus 2ab cosine C. Now don't freak out if you don't have an a and you don't have a b. Don't let the variables dissuade you. All you need to know is two sides and the included angle. And those two sides go right here, right here, right here, and right here. The included angle right here. We're good to go. Here's our unknown, which will eventually be side C. Okay, let's plug in what we know. Well, we don't know c squared, so let's just leave that. We do know 720.51 squared plus 411.11 squared minus 2, here we go again, 720.51 times 411.11. I need a little bit more room. Hopefully we can just move this over. Oh, almost. Close. Just going to move it over a little bit. I hesitated a little bit too long there on the 411.11 times, I need more. When in doubt, go for more. Maybe I can group the whole thing. I'll try that. Make it a little bit easier. No, not that. Oh, I'm telling you, it's work out there. It's rough. It's tough. We're gonna have to go a little bit at a time. Can't quite group it because I'm already inside a picture. Is the problem? It's okay. So then we're going to go times cosine of 95.19 degrees. Okay? And now we can keep going. A word of caution here. Be careful when using the law of cosines with your order of operations. This one's pretty straightforward, but sometimes you have to move these things around a little bit, and it can get a little dicey. But just remember, order of operations says that you have to do your multiplication from left to right before you do addition or subtraction. So just keep that in mind. It's not a huge deal. Okay? So when you figure all this out, when you jam on this for a while, you will get C equals 861.2406563. And I write all this down because I want to remind you to keep a lot of digits, as many as you can. As I said, use second answer as much as humanly possible until the very end when you'll report answers 720.51 or 411.11. This is to the nearest hundredth of a foot. But until that final rounding, you want to use second answer, you want to use store, recall, or just write down a whole bunch of digits, because in trigonometry, if you round, you'll get further and further and further from the correct answer. And precision is important here. You can easily get a couple of feet off, 3, 4 feet off, just by rounding, and that's not good. So keep lots of digits. Okay. So now we have that this is 861.2406563. Now you'll notice, as we talked about earlier, when you know an angle and its opposite side in a triangle, and then one of anything else. So we have these two, and this is money. And then we also have one side here, which will allow us to find this angle right here. Or if you're opposed to that, you can find this guy up here. They're different. I want to point out that these are not 45 degrees. Just because this is drawn through a 90-degree angle, it doesn't mean that this angle here and this angle here are congruent. Sometimes it looks that way, but appearances can be deceiving. Don't believe it. Let's use the power of the law of sines to figure this one out. Okay? So for now, I'm going to get rid of this so we can keep everything visible on our screen. You all can hopefully just write more. So now we can use the law of sines because we know some opposites. When we know that, we're good to go. Okay, from section 9.3, the law of sines was sine C in our case over little c equals sine, well, let's say B up here, even though it's not B, it's really CBD. Maybe I should put that. Maybe I should be correct. Sine angle CDB. So we'll get this red one down here over, well, what's opposite that? Let's look again. CDB, opposite of that there's our good friend 720.51. Okay? I could have put CB. Maybe that's to be consistent. I should have done that. I don't know. All right, CB. And then we'll go down one step and do the other one. So then C we knew was 95.19. So I'm going to go sine of 95.19 over C we know to be 861.2406.563. And I just left that in my calculator. I'm going to hit second answer. And that equals the sine of angle CDB, which we don't know, over CB, which is 720.51. So this isn't so bad. I'm going to go down here and see if I can extend just a little bit so we can work on this. Okay. Now, as always, we're going to cross multiply and divide. And so we're going to go sine of 95.19 degrees times, I might put in that parentheses just to make it look easier, 720.51 feet equals the sine of angle CDB times 861.2406.563. And you really don't have to write all that because, again, use second answer in your calculator as often as you can. Okay? And I have my calculator here. I'm going to leave that up on the screen so you can be doing that while I am. And then I'm going to go and I think I'm going to store that one that I had, the 861. I think I'm going to store that. Store and alpha D for distance. Okay, pretty good. And so then I am going in my calculator to take the sine of 95.19 times 720.51. This isn't very exciting for you all, but I think it's better to just leave that there rather than bring the calculator back. So you don't do this with me while I am. Okay? So then I'm going sine, and then I'm going to go recall. C. And I'm going to, I thought about this a minute. I think I'm going to pause for right now, do my work, and then jump back in while you do yours. I'll catch you in just a second. You won't notice a thing. All right, we're back into it. So I did some computations here and wrote this out. And then when I did, I got the sine of angle CDB, which recall was up here, angle CDB. I got the sine of angle CDB equals 0.833165568. And again, just leave that in your calculator. You don't have to write it out. So a lot of people right here kind of panic because this doesn't look very friendly. But this, remember, is just a ratio. This is not an angle yet. It's just a ratio of side lengths. Okay? No big deal. So in order to get an angle out of that, again, make sure you're in degree mode. Make sure you're in degree mode. And I hope you are already because you took sine 95.19 earlier. But just anyway, we're here. So then you can go angle CDB equals approximately the arc sine. In order to get that, remember, arc sine of, and then to get that answer in here, clean that up a little bit, just go second, and then it's the minus key, which is answer, second answer. And it will take this ugly decimal here and put it right in there. Take the inverse sign of that. And when you do, you'll get a much friendlier answer. You'll get angle CDB is approximately equal to 56.42530426. And again, you don't need to write all that out. You can just take that and store it somewhere. Hit store, the store button, and put it somewhere in your calculator, E, wherever. Store in and then you'd go alpha E if you want. You don't have to. You can write it out. It's fine. But using the store is pretty handy at times. Okay, at this point now, I think you can probably figure the rest out on your own. You have most of what you need. Um, this is 56.43 approximately 56.43 degrees. So see, check this out now. You know this angle, you know this angle, you can get at this angle if you want to. Recall what the little box means. That means you can get this angle. That means it'll just all fall out. And then hopefully in the end, you will wind up with um, these values right here. So um, hopefully this has been helpful to you. Sorry I'm not here. Enjoy the rest of the period with your classmates. Work a little, talk a little. You know what I'm saying. And as always, happy math. Thank you.